Hi, welcome to Palai Planet, and we have got a question from circles. It's a very good question because this is going to use not only circles but it is also going to use Pythagoras and as well as trigonometry. So please watch this video. You will be able to understand this question and how to solve it. It's a very good question. So the question says that in a circle of radius 21 centimeters. So there is a circle, and suppose this is the center point, right? And in a circle the radius is 21 centimeter and an arc subtends an angle of 60 degree, right? So let's first figure out where is this arc. So suppose this is one radius and this is the other radius. So that means this angle is 60 degree, right? And suppose we have this point which is center is O, and this point where this radius is meeting, that's say A, and say this one is B point. Now what we need to do is we need to find out the length of the arc. Now this is the length. So suppose this point is P, so we need to find out the length of the arc APB. So I'll just do it here because we are going to run short of space in this question. So the length of the arc, and that arc is say APB, is equal to theta upon 360 degree multiplied by 2 pi r, right? Now we already have the value of r and as well as of theta, so let's put both of them into this question and we will get the length of the arc. So that's like 60 over 360, right, multiplied by 2 multiplied by pi is going to be 22 by 7, and r, so r here is 21 centimeters. So that means this is OA is 21 centimeter. Similarly, even this is 21 centimeter, right? So this is 21. Now let's start simplifying it. So this is like 6, 2 makes it 3, 3 makes this 7, and 7 cancels this 7. So this is equal to 22 centimeter. So that means the length of the arc is 22 centimeters. So that's one thing which we have just solved here. Another thing is the area of the sector formed by the arc, right? So that's also very simple because we already know that the area of a sector which is formed by an arc, right, that's always equal to theta upon 360 degree multiplied by pi r square. And now let's again put these values and we will find out the answer. So once we put the values, it's like 60 over 360 multiplied by pi r square. So pi is 22 by 7, r square meaning 21 multiplied by 21, right? So now I'll start solving it. This is like 6, and 2 times it is 11, and 2 it is 3, 3 makes it 7, 7 gets cancelled here. So it's finally 11 multiplied by 21. So we can say that this is 11 multiplied by 21. So finally the answer which comes is 1 and 2, 3. So 231 square centimeter. Now that's the area of the sector formed by the arc, right? So this is what it is. Now the third part is, which is a good question, and that says that the area of the segment formed by the corresponding chord, right? So area of the segment formed by the corresponding chord. So let's first see that where is the chord. So chord is this, right? So this is the chord. AB is our chord. Now what is the area which is formed by this chord? This is the area, this entire thing. This is the area formed by this chord, and we have to find out the area of this part, right? So let's form the base relationship, and it is like this, that area of the segment, this segment, right, is equal to the area of this sector, which is this entire area OA, this entire area, right, this one, this entire area, which is the area of this sector we just calculated, area of the sector minus the area of triangle OAB, right? So once we have these two things, like area of the sector and also the area of the triangle OAB, we can find the area of the segment here. Now we already have this, we have just calculated it here. What we need to calculate is the area of the triangle OAB, right? So let's find that out, and to do that we will have to find out the length of AB, because we know that the area of any triangle is equal to half into base into height, right? So we don't know the measurement of the base, that is AB. We also don't know the height here. So let's find out both of these two, and then we will solve the question further. So first we do a little construction, and we drop a perpendicular from O onto the chord, right? So we already know that whenever there is a perpendicular which is dropped from the center onto any of the chords of a circle, that means this perpendicular is going to bisect it perpendicularly. It's going to bisect the chord perpendicularly. So that means A, and if this is, say, this point is, say, X, right? So that means AX is equal to BX, right? And also what we can also do is that we need to observe these two triangles OAX and OBX. So let's observe these OAX. Let's observe this triangle OAX and triangle OBX, and when we do that, we will find out that OA is equal to OB, because they both are the radii of the same circle. OX is common in both of them, right? Because that's the that's this side, this is common. And the third thing is that AX is equal to BX, because that's the because whenever there is a perpendicular on the chord, it divides equally. It divides the chord equally. So that means AX is equal to BX, which means these two triangles are congruent to each other. And if they are congruent, then we can say that these two triangles are also equal to each other, right? So each one of them is going to be 30 degree. This is going to be 30 degree. This is going to be 30 degree, right? And now after doing circles theorem and now we will be using trigonometry in this. So what we are going to do is, let's consider now triangle OAX once more, and in this we will write triangle OAX. So in this we will write sine 30 degree. Sine 30 degree is always equal to, we already know sine is sine theta is always equal to opposite upon hypotenuse. So when we are talking about the triangle OAX, in that this is 30 degree, right? So if this is 30 degree, then this is going to be the opposite, so that is AX. So AX upon OA, that is hypotenuse, so that's going to be 21. So we can write that the value of sine 30 is 1/2, so that's like AX upon 21. So we can say that AX is equal to 10.5 centimeter, right? So that means this is 10.5 centimeter, right? Now from here we also need to find out the value of OX. Now OX is to be found out from this, right? We need to find it out with the help of cos theta. So now let us observe the triangle OXB. Triangle OXB, and in this cos 30 degree is equal to, and this is equal to OX upon OB, right? Now we already know the value of cos 30 degree, that is always 100 and √3/2, right? And OX we need to find out, and OB is already available, and that is 21. So we can now say that OX is equal to 10.5 √3 centimeter, right? And now it is very simple, because now we have got the value of the base of the triangle, right, and also the height, and we will put both of these values into this formula, and then we can find out the value of our triangle OAB. So we can say that the area of triangle OAB is equal to half into base. Now base is entire AB, so which is double of AX, and AX was 10.5, right? So that means complete AB is going to be 21. So we will do this 21, and the height is this, which is OX. So that's like 10.5 √3, right? So this is like 10.5 multiplied by 10.5, and the value of √3 is 1.732, right? So let me now take the help from my calculator, and we will quickly find this out. So that is 10.5, yeah, 1.732. So that's like 190.95 square centimeter, right? And now we are going to put this value, right, into this formula, and we will get the value of the area of our segment. So the area of the segment is equal to area of the sector. Area of the sector was this 231, so that's equal to 231 and minus the area of this triangle, which is minus 190.95. so this is equal to 31 plus 9, and that makes it 40. So this is like 40.05 square meter. Now that's the answer, and I hope you could understand this question. It was a very, very good question. Keep watching these videos and you will learn soon how to solve these complex questions. Thank you so much. Have a nice day and bye bye.